Supposedly it's recording. I'm hoping my voice sounds good. So I'm not really. Okay, here we go. So problem 62 from chapter 9 of the Hibbeler textbook. It's saying to locate the centroid of x and y of the shaded area of this random shape. So what I like to do is break it down into components, and then I have this nice table here where I'm gonna write everything out. Also, I will be using this as a guide for the centroids. So that's for the right triangle, this is for a rectangle, right? And so on, for each of these. Yeah. So we're just gonna dive into the problem, and we're gonna get going. So like I said before, I'm gonna separate it into components. So I'm gonna make this big triangle, component 1. Then what I'm gonna do this little square here. That's component 2. Then I'm gonna do this small triangle here. It's my third component. I don't know why I use Roman numerals, but I do. And what I'm first gonna do, I'm gonna locate the centroid of each one, right? So like the centroid of this one is gonna be in the middle, right? It's 3 inches, and then it's gonna be 3 inches height-wise, right? And so for the triangles, it's gonna be like 1/3 to get the x value of the x value there, so that's 2 inches, right? And the total length is 9 inches. So 1/3 of that. Actually, if I did 1/3 of that, it would be measuring from the top, which is 3 inches. So to the bottom, which is what I need, 6 inches. The reason I need it from the bottom is because the way this is drawn, my axis is. So this is my y, this is my x. So this is the positive sense, this is positive sense, and this is negative sense, and so on. So I need to measure it from where it's 0, right? And that's where I get that 6 inches. And then technically this is negative 3 inches because it's in a negative sense. And then when I'm looking at my third component, my center, it's going to be like somewhere here, right? And it's going to be 1/3 of the height going this way, because you always do it from the fat end, the 1/3, which is just 1 inch for this part. So it's really 7 inches in total. And then for my x component, I'm just going to put it up here because it's 1/3 of the 6, correct? So it's also 2 inches, but it's negative 2 inches. So when I'm looking at this, I'm going to go ahead and do my one component where I'm going to have 2 in the x, 6 in the y. And then for my second component, I'm going to have negative 3. And then I'm going to have 3. And then for my third component, I'm going to have a negative 2. And then I'm going to have a 7 in the y. So now all I have to do is calculate the areas of these, and then find these, and then I can find the sum of them, the sum of the area, and I can, and since my x bar is simply just going to equal to the sum of my y bar, or, well, my bad, the sum of my x bar times a over the sum of my a. And the same kind of sense to the y bar, with sum of sum of y bar times a over sum of a. That gives me that. So now, like I said, all we have to do is calculate the areas. So for number 1, it's simply just going to be base times height over 2. In this case, my base is 6 inches, my height is 9 inches. Over 2, that's going to give me, let's see, 9 over 2, 27 inches squared. And then for the same thing, I'll do the same thing for number 2, which is just, it's a square. You can just do, technically it's base times height, right? But in this case, it's just 3 times 3, which gives me 9. Oh, my bad. 6 times 6. I don't know why I put 3 times 3. It's 6 times 6, which equals 36. And then you do this same thing for your third component here, which gives me similar. It's base times height over 2. And that's going to put me with 6 as my base times 3 as my height over 2, which gives me 9. Yeah. So I just plug these into here. So we have 27, we have 36, and then we also have 9. And then I can do the sum of the area real quick. So 27 plus 36 plus 9, which gives me 72 total. And then I'm just going to write out the rest of them. So we have 27 times 2, correct, which is 54. Negative 18. And then 36 times 3, which is negative 108. So this negative does cause that to be negative. So we're going to have 54 plus negative 108 plus negative 18, right, which gives us a total negative 72. So, and then now we do the same thing over here. So we do 27 times 6, which gives me 162. We do 36 times 3, gives me 108. And then we do 9 times 7, which I don't know why I didn't do my head, which gives us 63. So then you use 63 and plus 108 plus 162, which gives you a grand total of 233. So using these basic equations, you can find x bar and y bar quite easily. So we have x bar, and it's going to be that negative 72 over 72, which happens just to be negative 1 inch. And then we have y bar is equal to 333 over 72, which gives me 4.625. So if we're looking over here, that means I'm gonna go ahead and just kind of erase all this stuff. So that means when we're looking at this piece here, my center is gonna be around here with the 4.625 inches wide, and then that 1 inch, negative 1 inch. And that's it. That's it for this problem. Pretty simple in a way, but doing this table is very helpful. It keeps you organized, and it keeps your thoughts and everything organized. Definitely would use this table for every problem like this. And if you have, you can do 5 components. You can do as many components as you need. So yeah, I'm gonna do a little bit of a harder problem now. So let's start.